Hey guys, so here's a new one for you. I bought a Bestek uh, inverter, a battery powered inverter that, let's see, it had a 400 or 45,000 milliamp hour battery in it. Well, the battery got unbalanced because it's a bunch of 18650s. That's what I believe happened to it. And now the inverter only runs for like 30 seconds at a full charge, and then it's completely dead. So I figured out a way to both repair this and upgrade it at the same time. Let's get to the bench. So here we are at the bench. This is the inverter. Used to sit inside of here. The screws broke off on it. It's been dropped a couple times, but I don't think that's the reason it failed. Here is the battery pack. This is a bunch of 18650s. It puts out 12 volts up to those are 15 amp hours. Upon taking this battery pack out of the device, I don't think I would ever buy another one of these. Not this particular brand, because if you look, they normally put the pins away from each other, like one on this side, one on this side. Not here. Those are both live. And they're right next to each other. So in essence, each one of these Bestek devices is basically a bomb. I will test the voltage. Here, let me make sure that the voltmeter can be seen in the shot. Ready? This will put out 12 volts. Well, it might not now because it might be dead now. Let me see. Now it's on 200. Sorry. DC. There we go. I was testing AC with it. Let's see. Yeah, there you go. It says negative because I have it on the wrong terminals, but there you go. 11.59 volts. Here, I'll flip it, get rid of the negative for you. There you go. 11.6. And it would not take much to jump that and cause this battery to explode. So this is a giant bomb. So I'm not even going to be trying to dismantle this battery pack because there's really no way to do it without being super destructive with it, and I'd prefer not to have a bomb in my residence. So instead, I'm just going to get some decent electrical tape, cover up all of these contacts, and I'm going to recycle this probably at Home Depot. Probably going to go to Home Depot and recycle this. There's another contact over here that I kind of want to cover. Another giant lug. So, yeah, if you have one of these, you might want to be very, very careful with it, knowing that those lugs are, in fact, that close together. Okay. Here is the inverter. And of course, this battery pack used to sit like that. Okay, instead of that battery, that is a 15 amp hour, we're going to upgrade it. That's the battery we're going to use right here. This is a 20 amp hour. It's a LifePo 4 battery. And it's super light. Super, super light. And on Amazon, I already bought the cable required, which is the XT60. This is the female end of the XT60. These lugs go to the battery. So in concept, I should be able to connect this to the battery, positive and negative, and connect this to here. And if the inverter isn't damaged, which I hope it's not, we should be good to go, and we should actually get a 5 amp hour upgrade out of it. So let's first get this set up. I will move this out of the way for now. I'll put the lugs on this battery. And then we will see what we can do here. Let's pin these down tightly. Want to make as solid of a connection as you can, because the max output of this thing is 150 watts. So we want to make sure that we're going to actually be able to pull that 150 watts just as we were able to before. So theoretically speaking, this fix is already done. So now if I take this and I plug it into here, we should have power. Since I don't want to get electrocuted, because this is going to step the power up to 120 volts, let's bust out some 12 volt stuff here, so that when I connect this, we can make sure that the 12 volt side is actually functioning properly. Here we go. Nothing exploded. That's a good sign. Let's plug this into 12 volts and see if we get power, which we do. Sorry about the flickering. There we go. I'll make it full on. So we get power. No problem with that. That's 12 volt side. I kind of expect it to have 12 volt side because it is a 12 volt battery. So that's not really too surprising. Here is a 120 volt load. This is a little teeny tiny purple desk fan. See if I can get this in the shot. Put it here. You guys see it okay? I'm going to plug this into here. And then I have to turn the inverter on. So I have to press and hold the power button for a minute. There you go. So 120 volts is working off of it just fine. So now we have a 120 volt load. We have our 12 volt load. So now all that's really left to check is the 5 volts, because it also does USB charging. So let me see if I could find something like, let me see. I don't really have anything that's not charged. That's the problem. Actually, that's from a previous video, the blower. Let me see. Plug USB in, turn on that. That's just USB. I didn't press it long enough to turn on the inverter itself. So here's the cable from there. See if it'll charge. Yep. Okay. So it is showing that it is charging. So that means the entire inverter still works. It was just unbalanced batteries, which happens quite a bit with the 18650 cells. And the way to fix that problem would be to take those 18650 cells individually out of the package, find out which ones are low with a voltmeter, and recharge the low ones to get them back up to the nominal charge of all the other batteries in that group. So an easier way to phrase that would be 18650s have a full charge of 4.2 volts. So if you have a battery in line that's at let's say 3.4 volts, after you have it plugged in and it fully charges up, the charger is going to take the first battery that gets to 4.2 volts, and it's going to call that fully charged, even though you might have some cells in there that are at 3.6 volts, which is very far from a full charge. So then what happens is, when you start turning it on and putting a load on it, basically the first battery to dip below 3 volts will shut off the device. So it'll think, okay, the batteries are dead, even though there might still be cells within that group that are at 4.2 volts. It's going to shut off because one of these cells made it down to below 3 volts. So that's the issue that I'm facing here. Using this battery, not only do I get an extra 5 amp hours out of it, so I'll be able to run stuff even longer on it. I don't have to worry about balancing. I can just take that battery and throw it on a charger and call it a day. Let's put this thing back together. Like I said, since the screws are smashed up here, because it was dropped, it only got dropped once, I am going to have to improvise with how to keep it closed, and I plan to actually use electrical tape. Wanted to use duct tape to do it. I might be able to use duct tape on the edge, but I usually just take electrical tape, and I'm thinking just spin it around that way. So first I have to disconnect this battery, because I might need to get my drill out and drill out the bottom of this, because I have to get these two terminals to fit. These terminals have to fit through here. And I don't want to cut the wire. I want to make the terminals fit. So let me get my drill real quick and see how big we can go on that. I think I need a bigger bench already. Okay, let's see. How big can we go with that? Even that won't be big enough, but it's going to take more than one go, I think, to drill this out fully. So let's see what we can do here. Let's see. It's just going to be keep testing. Nope, not even close. So let's go bigger. How big can we get it? Okay, bigger. This one you gotta, I should have stepped it up a little bit more with a couple of bits, but there we go. We're in. Now the only thing you have to keep in mind is there's a fan that's also in here that cools off the circuit board, but I am nowhere near that fan. Will that fit? That's getting much, much closer. I only have one more bit that I can go up on here. And then I might have to round out the hole. Let's see. Do some rounding out of the hole. Sorry, it's off camera. really hard to do this on camera. They just about fit. Let me round that hole out slightly more. Okay, almost. I mean, it'll pop in, but that's going to be really difficult to push it through there, so it's just going to take a little bit more. If you're wondering what I'm doing, I'm just doing this. Okay, it's a pretty sizable hole. Yep, okay. We got the size of the hole that we need finally. Now I can put the drill away. Get this off the table. Okay, now drill's gone. Now we have to figure out how to fish this wire through, because I'm going to want this to stay inside. I want this to go through here. And my hands do not fit properly. So I was thinking maybe use another piece of wire to pull that wire through. Here's another piece of wire, a much smaller piece of wire. And what I can do is push this wire through here so that it goes through this hole here. Have it come out in here. Let's see, where is it? It's way down there. There we go. So now it's through and through. Tie these to here. If I can get a decent little knot in it that won't slip. And try to pull it through and see what happens. It's there. It's where I want it to be. Here's a pair of pliers. There we go. Now I can get rid of this. And now the wire's coming out the bottom. So there we go. Easy enough. Okay, let's feed the wire back through, because now we need to connect it to the board here. We'll clear everything out of the way. Move the battery. And this project's pretty much done now. So now what we need to do is connect this for power. Make sure it's the right way around, which it wasn't. There's power. And connect this to the fan, which you have to start putting it. There's a rail inside of here that the circuit board sits on to sit off the ground. So there you go. Pull this through slightly. Okay, here's the fan connector. Gonna go right on there like that. So we got our fan and we got our power line. So let's pull it through. Pull everything through. And there we go. That's how it would normally sit, but you could see where it's cracked on the top. So what I'm going to do is a super quick fix for the time being. I'll figure a better fix out later, but for the time being, we don't want to cover this fan. So I'm going to want to come over here more toward the 12-volt side, I think, and just put some super tense electrical tape on it. just like this. Just put a couple wraps of electrical tape. One more should be okay. And then I will get out my trusty knife. Cut it right here. So now that side won't open. So now I need some for the other side. So this side's still loose. I'll put it right here between the switch and 120 volt side. There's nothing under here that I have to worry about on this side. There we go. Very crude fix. But like I said, this would have ended up in the garbage if I didn't think to use another battery on it. This would have been thrown out, and I don't want to throw it out because this does get tons of use. We've used this in all of our videos that we went out in the woods at night and had the woods lit up, and we were looking for beavers, and that all those videos were filmed using this inverter. So let's see now. Let's make sure everything still works. So we got our inverter now. We have the wires coming out of the bottom of the inverter now. And this is good because this means that you can hook it up to car power. You can hook it up to bigger batteries. I have a 30 amp hour 12 volt battery on order. And that should be here in a couple of weeks. And that 30 amp hour battery will be doubling the runtime that this inverter had off its own batteries, which is amazing. All right, so got our battery, got our inverter. Let's cut some power here. That way there you'll be able to see all the lights come on. So that's to tell you the machine's powered up. That's basically telling you, since this light's not on, it's telling you that the USB ports are good to go. You never need power for the 12 volt. The device can be completely turned off, which I just did, and any 12 volt load that you plug into it will just run. This is a 12 volt spotlight. So any 12 volt load you plug into it will just work because it's just fed directly off the battery. Okay. We will try again with a fan. See how that works. Turn the power on, hold it until the green light comes on the switch here. Now the fan ramps up. Let me go get a light. We'll test it out with a desk lamp too. See if we get any flickers or anything. We shouldn't get any flickers because this is a sine wave inverter, so it should not flicker at all. Here is a desk lamp. And all seems to be working properly. And the fan's still running, so I'd say that's a success. I'd say I'll probably be able to pull the whole 150 watts out of it. And then if I need more power than 150 watts, we switch over to the generator. Watch out, the lights are coming back on. So there we have it. There is our fix of the Bestek portable power station. It's a sine wave. Like I said, it is a sine wave inverter. And that's the big reason why I keep it around and why I want to keep it running. My generator does not do sine waves. I have no problem running laptops and stuff off of this. And believe it or not, even on the battery pack that came with it, this would run my laptop probably 9 hours, 9 or 10 hours on a single charge with this inverter. With this, I'll probably get 11 or 12 hours out of it with this battery. When I put the 30 amp hour battery on it, I'll probably get more like 17, 16 hours. So it's definitely a worthy upgrade if you don't mind having cables sticking out. Other way you could do it is to actually properly balance the batteries, but like I said, the terminals on this battery pack being that close together is ludicrous. I've never seen that before. I do not trust that at all, because all it would take is a screw, a little piece of metal, maybe a component like a resistor or something that gets knocked off the board and just jumps those two terminals, and congratulations, you just made a bomb. So that's very dangerous in my opinion. In conclusion, I'd like to say thank you for watching, and if you have any other projects that you'd like me to tackle, please feel free to leave a comment. Thank you.